ఉండగలదా మరి ఎగ్జామ్ అయిందా? ఉండగలదా మరి ఎగ్జామ్ అయిందా?
Good morning, everyone. I welcome today's resource person Raghavendra to this second day's session, which is supposed to be hands-on one. And I once again congratulate the Department of Computer Science and Engineering for having chosen such a resourceful resource person who is a practicing scientist from what I heard from the resume of Sri Raghavendra. We rarely find such people who are having a passion for teaching and interacting with the students to share their experiences. So it's a really great privilege for us to have you here, sir. And it is up to you to take the most advantage of such an interactive session with such resourceful persons. I wish the second day session a grand success. Thank you.
Virtualization setup. After that, I don't do. I just set up it. Later, we go to our slides. Now, when you go for virtualization, so what virtualization does? We said that it's like a cloud operating system. Is it right? So I need to get multiple operating systems. Now, can you tell me multiple operating systems? Anyway, I can do now. Let's say, for example, I want to do Linux and Windows. How do I do? Then load Linux, then after that first load Windows, then after that load Linux. So when I want to work on the Linux, what I will do? You reboot it, go to the Linux. Right? I don't want to do that. I want to run both simultaneously. Probably I write one socket programming. The socket programming for Windows I will write. I need to send a message to the Linux. So from Linux again I want to receive and start to the Windows. Let's say that I want to do it on a single laptop. How do I do? How do I do? Is it possible? No? Okay, if I want to do, how do I do? Yeah. So there is something called as the virtualization softwares. For example, migration. Okay. Any other migration is not software. I'm saying. It's software. How about something called a VM player, virtual box, or VM workstation? What they do? Put a Windows. On top of the Windows you load either the VM player or VM workstation or virtual box. Again, inside that you load another operating system like Linux. Do you know what you can do? You can run Windows and the Linux operating system through the virtualization software simultaneously. You need not to reboot. That is called as the virtualization. So when you see the virtualization, it basically gives an illusion of having the things. Like for example, to run two operating systems, you need two processors now. But right now you are doing it only single process. So what the virtualization does? It actually does the logical partitioning of the resources. This is what the virtualization does. Right? So you are doing the logical, not physical. What is physical? You need to break your artificial processing. But you are not breaking. You are only doing the logical. How about something called virtual memory? What does virtual memory does? Illusion of having larger memory is virtual memory. Yes or no? So what are the techniques you use? Something called the paging, demand paging, segmentation. Sir, similarly, here also what the virtualization does is, it creates a layer and this layer will allow to use the processor so that multiple instructions from multiple operating systems can be executed. You feel as if you have many processors, much memory, but in fact you don't have. That illusion is given by the virtualization. Like for example, I'll just put you one more thing. For example, let's say that I want to make one system with only 256 MB RAM, with maybe 10 GB hard disk, and running with Windows operating system. But if you do normal things, when you load operating system, it will give you the entire resources. But in this case, what it happens? It will give you only the resources that you wanted. That is what you can do with the virtualization. Is it right? So if you see this is what it does. You have one system that you feel as if you have many ones. Is it right? That is called as the virtualization. Now, virtualization when you do, there are two types of virtualizations in fact. There are two types. Please make a note of it. There are two types of virtualizations. One is called as a type 1. The second is type 2. Type 1 and type 2. Right? Type 1 runs on the bare metal hardware. Type 1 runs on the bare metal hardware. Bare metal means it doesn't have an operating system. You take a hardware and load it. That is called the type 1. And the type 2 is called as the hosted. Hosted. So what the hosted? It runs already on the existing operating systems. The VM player, VM workstation or the virtual box are the examples for type 2. That means on your laptop, you want to run both Windows and Linux, and you don't want to erase your Windows operating system. Then what you select obviously? The type 2, which is called hosted, because you are putting on the existing operating system. And when you use a type 2 hypervisors which are called hosted, they have performance degradation. They are not meant for industry applications. Industries will look for what? The type 1, where you will directly load it on the bare metal hard. Is it right? So where you can create multiple operating systems. That is what we try to see. Now I will stop it here. Now let's first try to understand the virtualization concepts, create some kind of application. So what try to do virtualization? Virtualization used for creating the virtual machines, where you can create multiple operating systems. Right? So we will stop it here. First create that. Let's see that how the virtualization works. Create the operating systems. Later we will when again continue the presentation when you go to the lab. Because next lab will be programming, that I will show you in the lab. Now we see that how do we make virtualization later. Fine? Now all are connected together. So now can I get 64 CPUs? That is a cluster. So building that SMK symmetric multiprocessor, which is very huge, which can actually go over a vertical, is very difficult to build and maintain as a technology perspective or as a maintenance issues. So instead of this, let's build a system which is loosely connected. So put a network, connect all the systems. Now what you need to build? You need to build the schedulers which can work on all these systems. Now the operating system doesn't run on one system, it has to run on 64 systems. That is what is called as the cluster. Now just see, if one of the system fails, no problem. The workloads will be distributed to the other systems. So that is what this is one of the technology which is actually before the cloud, the cluster. Right? A group of systems which are interconnected together to get a performance out of many systems. That is called a cluster. And clusters are meant for high performance computing or high throughput computing. Now later, there is another technology which is came, which is called as a grid. Now what is grid? Grid is basically a group of clusters which are interconnected. Like computer science department has one cluster, which they are using it for some computer science applications. And there is an electronics department, PCE, so they build their own cluster, which they are using it for some electronics design purposes. And so there is a mechanical department, which they have clusters. Now, I would like to join and make some applications which can work multidisciplinary applications. Then what I can do? I can connect together, then I can call them as the grid. So the grid is what? A group of clusters. That is the grid. But the grid is talked about more into the larger perspective. Like the different countries, they wanted to do some kind of a research collaborative work, then they established a grid, which is called as the global grids. It's a grids. Right? So the grid is what it is doing. It is also giving you the computing power. Let's say for example, I'll just say you one question. How many of you know PICSAT? Pixar చదివారా? Pixar, what is the complexity for Pixar? What of? N log n. N log n. N is for what? Number of iterations. Each iteration will take approximately log n computations. That's it comes to n log n. Simple. ప్రతి సార్టింగ్ n ఉంటుంది, పక్కన log n కానీ n కానీ ఉంటుంది. అందుకే n log n ఉంటుంది, n square ఉంటుంది. సింపుల్ కదా? ఇంకా డౌట్స్ ఉంటే వీళ్ళు చదవండి ఒకసారి algorithms. Now your Quicksort, now what it does? Quicksort also does something called as a divide and conquer process. Right? Did you see? Divide and conquer, what it does? It divides into smaller chunks and each chunk will be executed. Correct? Now let's say the question I will ask something like this. Now you are designed, probably you made a modified Quicksort using something else. Like general Quicksort, what you do? You have something called the left and right pointers with pivots. So you designed your own technique. Now what you want to do is to run my Quicksort. You said that probably my Quicksort runs much better. I want to test how does it run on some 100 systems. That means you need what? 100 processors. Now I would like to test. How do I get the power? Can my laptop support it? Can one desktop support it? Or can the server support it? No. Even if you go to the server, hardly you have maybe two processors, 3 processors, not more than that. But you need how many? 100 processors, or maybe 100 cores. Right? So this is what when you go for a grade, the grade people what used to do is, they used to take the resources that are available. Like there are pick up some resources from computer science, or maybe some India, and pick up some resources from something like some China, and pick up some resources from something like in Australia, and pick up some other country, join all of them. Whenever you put a request, I need systems of 100 to run my algorithm. So they used to provide it. That is why it used to call as the grid, the one formulation of the grid which is called as the utility grid. So what utility grid used to do? Whenever you demand the resources, these resources were delivered to you on demand. As a utility, the way the other things are served, like water, gas, electricity, telephone. So these utilities were delivered as a grid perspective. So that was called as the utility grid. So what is utility grid? Utility grid is meant for delivering the computing resources to the network based on the demand. And this was meant for research and collaborative activities. That was called as utility grid, right? And the utility grid was famous till 2009, until 2010. It was still famous, right? Now later, you heard about something Garuda grid. There's a grid from SIGAT, it's called the Garuda grid. So the Garuda grid people also, when you put a request, the research collaborative partners of them, they used to give the resources. You take it, you run your applications. Because you want to see how does it come up. Right? So still it was famous now. The industry wanted to adopt this grid perspective, which is the utility grid perspective. The way the resources of demand for research and academic purposes, can we give similar kind of resources for the industry? So that transformation of the utility grid was made, which is called as the cloud computing. Right? So the industry named it as a cloud computing. But otherwise, it is basically the utility grid. Now, the clouds come into picture. So what the cloud does? The clouds deliver you the resources which you require on demand. Right? So for what? Because you want to have what? Some applications which are more compute intensive, or which are more data intensive, which you need a lot of computing power, which you cannot get it from the resources which are available. Right? So that's how the transformation has come. That's why whenever we see the grid clusters, they all comes under distributed computing. Clear now? Now, let's see that how do we do. So whenever we want to understand, so as academic now, they will ask about the definition. Cloud computing, you tell me the definition. If you tell the definition right, then I give the marks. Otherwise, they won't give the marks. And people will give different definitions. Now, we will not stick to any of the textbook definition. That we'll try to see on our own. How do we do? Right? So by this time, everybody knows the cloud. No? What is cloud computing? It is basically a utility computing model. So utility computing means what? Served on demand. It is served on the demand. Fine. Now whenever it is served on the demand, who is serving it? Somebody is serving it. So that person is called as what? The provider, service provider, and somebody is there who is consuming it. So it's called as the customer or the consumer. And whenever the provider serves any kind of resources, he will promise some quality of service. What is quality of service? Like for example, when you go for something called some telephone provider, no? Whenever they say that, oh, I said that whenever you whenever you purchase any kind of a bandwidth, they say that I will give you 256 kbps. And they say that it's a 2 Mbps without any downtime. What does it mean? It is a quality of service. So they are promising to give you that kind of a bandwidth, right? So quality of service is given by whom? The provider. And whenever you have, there is an agreement, because the provider is giving you the services, you are consuming them, so you should abide by some kind of the agreements between whom? The provider and the consumer. That means there are some service level agreements, so that you cannot violate. Either you cannot violate or the provider cannot violate. So there is some service level agreements, and all of them when you combine, and what you need? You need what? You need basically the computing power, which is called as an infrastructure, platform, which probably you need some development tools, or services which you need to use the end applications. That's what we use, right? So just try to put all of them together. Now can you say that? How do we define a cloud? Cloud computing is basically a utility computing, which is called as pay as go. Use them, and whenever you don't want, you leave them. So pay as go computing utility model to deliver the infrastructure, that is your computing power, platform, your development tools, and applications. You want to use the end applications as a services over where? Over the internet. Over the internet, based on service level agreements between the providers and the consumers, meeting the quality of service parameter. This is what. No need to buy now. You know now. Somehow. So that is what we say that cloud computing is basically getting some services between the providers and consumer, between some service level agreement and quality of service parameters. Understood? So now, to establish, now what we need to understand? We need to understand what is infrastructure, what is the platform, and what is an application. Infrastructure is what? Your computing power or storages. Platform is for the development tools, and applications are the end applications which will be delivered, which is called as a services. Right? So now based on these things, let's try to understand how this cloud computing we can deliver, or we can build them, or how can we use them. That's what we're going to say, right? Now let's see that how do we do. There are different types of public clouds, like a private cloud and hybrid cloud. So not to put too much of in this, I just talk about a public cloud. Heard about something called Amazon? Amazon. What's Amazon? Okay. More than that, there is Amazon, which is a book selling company. You know that? Amazon was started, it's a world famous bookseller. When Amazon search, you won't get that Amazon web services. What you get? You get Amazon book. You can place a request for a book, you get the books. That's the Amazon initially. Now, how they used to deliver the books? There are two modes. One is you place them, they used to courier it, no? They used to send by parcels. And then another way they used to send you the digital books also. Right? Now, Amazon thought like this. The way I am sending the digital books over the network, can I sell the computers also over the network? It means not that you put a request, they take your request, and they take a box, parcel it, pack it, and send it by courier. Not that way. They wanted to sell the computer over the wire or the wires. No box parcel, nothing. The way the digital books are come, they want to sell a digital computer. That's why they developed something called Amazon Clouds. Now if you register for Amazon Web Services and Cloud, all the computing that you wanted that you can see on the screen. That's the public clouds. That means the public clouds will enable you to bring the resources from the network. So the examples for them is, we have Amazon and also the Windows Azure, and then something else Google App Engine. These are public clouds. Right? So when you see that Amazon or Windows Azure, they will deliver you network. And when we talk about the Google App Engine will allow you to develop the web applications over the clouds. That means you need to have any kind of the development software. The development software also comes from the network. That's what Google App Engine does. Google App Engine is for cloud web application development. Windows, Azure and Amazon is for computing power delivery. Other one is web application development delivery. Is it okay? That's what the clouds of the public cloud companies areas does. And there is something else also. Now when you go for a private cloud, when you go for a public clouds also, what you need? Like Amazon, if you take, you need a resources which you need to build the computing power. But if you want to build on your own, you need what? Similar kind of a setup, right? So in order to do that, there are some technologies which are called as the virtualization technologies, which is called as the Xen or VMware, right? So what is this virtualization? It will allow you to create multiple operating systems, right? It's a cloud operating system. So now we are trying to use today the Xen. We will use the Xen and create the infrastructure, cloud infrastructure. If I want to develop on my own. And the similar kind of setups are used by the public clouds. Is it right? That we'll try to see how do we map that. Now, apart from this, there are also some packages called OpenStack and there are open source things which also can be explored, right? So, OpenStack also similar to that Xen other things, but OpenStack is pure into the open source. Xen is part of both commercial and open source. Okay, that we'll see later. Now, once we build the infrastructure, what we need to have the models to utilize the resources, right? So these models are thread model, task model, and map models, right? So to set up this, what we are going to use this today is Aneka. A-N-E-K. Aneka is the tool which is used for cloud programming. Cloud operating system, what we are going to use? Xen as a cloud operating system. And we build a private cloud which probably similar to the public cloud setup. Similar, not exactly. Similar. Is it okay? That's what we try to see. So first is let's understand what actually that what we call evolution basically the kind of industry. So when you say that in the case of classical computing, within 18 months they change. So I need to change that. But when you come here, probably it will be given by the cloud model. So I need not to work about setup and get India cloud when you go, somebody will manage it, right? So I will not do on my own. That's why industries will get benefited from this. This is meant for the industry standard basically. Now, I don't know whether it's not coming up. Actually, this is like a pyramid. This was kept like a pyramid. So its color is not matching the time. Okay. So when you see like an architecture of a cloud, the cloud architecture is like, you can say like it's like when you put like a triangular shape. So on bottom you have something called infrastructure, then followed by platform, then followed by software. Probably everybody knows. What do you call the down layer? IaaS. Infrastructure as a service. The middle one is platform as a service. The top one is then I will tell you what is platform as a service. Infrastructure service is what? Which will give you the computing, which will give you the storage on demand. Fine. Infrastructure on the demand. What is platform as a service? What does it deliver? Deployment of applications. Deployment of applications is a platform. Where will you deploy? Give you the development tools. Okay? Anything? Anybody who says like any other answer? What is platform? Yes? Anybody says OS? Operating system? That's wrong. It's not operating system. Platform as a service will deliver you the development tools for designing the cloud applications. Where the operating system comes, it comes in the IaaS. Operating system will not come into the platform as a service. Databases also doesn't come into the platform as a service. Where they come? All they comes into the infrastructure infrastructure as a service. Platform as a service will enable you to develop the applications for the clouds. Then finally what it comes? Software. Like for example, when I say, you just map it. Let's say for example the QuickSart. I want to design a QuickSart which can run on the cloud infrastructure. Now what is my application? QuickSart, which comes into the cloud app. Now to design this, what I need? Some development tools. So probably what I can pick up? The thread model. So thread model comes there. Platform as a service. And where this instruction should be executed? Onto some hardware. So where it comes? Infrastructure. That is where you should be able to differentiate. Is it right? So that is what the cloud architecture model says. Now let's see that how do we build it, right? Now coming to the types of clouds, so there are different types of clouds. What are the different types of clouds? So you have something like a private, public and hybrid. So private is for own network, public is for public network which everybody can subscribe and use, and hybrid cloud is something when you want to have a federation. In the sense, let's say for example, I have something called 100 systems, 100 resources. Maybe I say that maybe during some peak time, I need some more resources. Maybe another 50 resources, which probably I cannot scale my private cloud. I want to give it to somebody else who can do only for just 1 hour. So I can do that federation, so which does the offloading the workloads from the private network to the public network, then that is called as hybrid cloud. That's what it is called as. It consists of the futures between the private and the public clouds. That is called as the hybrid. Okay, that's the hybrid cloud says. And there are so many technologies, like so many technologies like virtualization. What is virtualization? Hypervisor. It is a cloud operating system, and there is some security because you are trying to put your applications maybe in the public clouds. So how do you secure them? And there are something called the pricing models. How do you design? Because when you use the resource, you need to pay for that. The next is going by quality of service and service level agreements, and going to be the on-demand provisioning. Then the scalability. How do you scale and rely on them? Then energy efficiency. Energy efficiency. This is one more good one. How many of you study algorithms? All know. Everybody knows algorithms. How many types of complexities we have? Space, complexity and okay, but cases you leave. Worst case, best case, average cases. Okay. Not so like whenever you have some kind of algorithm, what's the worst time taken, what's the best time taken, what's the average time taken. So that's we use big O for worst, theta for average, omega for best. But time and space. Now, when you run algorithm, it will also consume some energy. And then it's mobile. మీరు మొబైల్ గేమ్స్ వాడారు అనుకోండి, అప్పుడు ఏమవుతుంది? బ్యాటరీ తొందరగా డిశ్చార్జ్ అవుతుంది. Similarly, there is some energy consumed by the computer. Now, can you tell me, when you run the bubble sort algorithm, how much energy is consumed? Is there something? No. Maybe see, you may not be studying, maybe your juniors may be down 2 years down the line, they will be studying. There is one more complex which is coming, which is called as the energy complex. So to check when you run algorithm, how much energy you can. Because nowadays energy is also more. It's also more important factor to us. Now probably they may now do the research. I designed my molecular algorithm to consume less energy. That not by mobile applications. Second, that's required when you want to consume less energy. That's what another criteria. So like this, we need to develop some programming and development. So this is basically for the research perspective. What are the different challenges? Each one is a PhD topic for the people to analyze and do some kind of a research. Okay? Right. Coming to that, now let's see that virtualization. Now it's network part of modern internet, right? And also the father of modern artificial intelligence. So if you see that John McAfee in 1961 he predicted that computation may sometimes can be used as a utility. And the same thing was done in 1961 said by Daniel Kahneman. He is also a member of Harvard. So they said that one day computation can be used as the utility. This is what the prediction was made. This right? So that means if you see, what is this utility? What we have the utilities? One is the water, gas, electricity, and telephone. Is it right? These are all the four utilities. Like the water to get, are we going to the wells and collecting the water? No. So there is a water pipelines being done. So you get the water through municipal pipelines. Is it right? Now, then come to the electricity. For electricity, are we producing our own electricity? No. So there are the connectivities done by the transport and which we get so the number of units we consume will pay for this. Is it right? Now next is the telephone. Are we putting our own telephone exchange? No. So we don't just subscribe to somebody. So somebody says that 1 minute, 1 rupee. Somebody says no minute business is a second business. Now whenever you call 30 seconds, no 30 seconds, just keep you 30 seconds cut. That means done based on the number of units you talk. Right? Now the next one is the way you have gas. Now probably if you see in some of the cities, major cities, these gas nowadays you get that big cylinders, no? So they don't have, even the apartments also they put a gas pipelines. So they put, and there is some meter will be kept, so the number of units that comes for a gas that you have to pay. So the way we use for water, gas, electricity and telephone, which is called as the pay and use. That means we are paying and using them. The same way is done, they predicted that one day computation will also be done that. One day computation is served as a utility. Understood? So that's what is called a utility computing. Now to serve as a utility, what we need? We need a network. Like what? For a gas, the network is established as a pipeline. For electricity, the way it is established as a pipeline. For water, the way it is established as a pipeline. Similarly, for a telephone, the way it is established as a pipeline or with the network connectivity. So we also need what? The network. That is why it says that once this network grows, it can be used as the backbone to serve the computer. That is why it is called as the utility computing model. And this utility computing model, later they wanted to do some name, and the internet was represented as the cloud. That is why it is called as the cloud. That is what the cloud. Don't think that's something else. So that's why whenever we talk about the cloud, again people say, sir, but the cloud is fine, but to use a cloud, we should have internet? Do you have a network? Yes, network is must. I'll ask a question. You purchase a mobile phone, if there is no provider providing you the services, can you use that device? It becomes a dummy device. So what we try to do? We try to see that, hey, our Airtel connection is very bad. Now let's switch over to somewhere else, something like an ID. Or if that provider is not doing well, then in this area ID is not good. Airtel seems to be good, so switch over to the provider of Airtel. So like this, we have an option to choose for our provider who can provide the connectivity without any interruptions. Yes or no? That is what we use the cloud. We need a network. Without network, it will not work. If somebody is saying, sir, network is not there, I cannot use. First you make your network robust. Build it. Then you can use all these technologies. Because everybody wants to connect each other. So this connectivity will come only when you have the backbone is very robust. Understood? So that is what we said that there is an internet, a transformation of the internet model is called as the cloud computing model. In first term the clarity on those pain, then you can go further. Clear? And the now let's see that then I'll ask you questions. Okay, now what we do is we will spend question times. Question and teaching, right? No more theory. Now the question is like this. We see that there is a web also. Web technology is also there. Then why, if web is already there, then why to name another name like a cloud? Just think. If already there is some technology like a web, something like an internet or World Wide Web, when it is already there, why to bring another name like another jargon like a cloud computing? Is it necessary? Storage? What kind of a storage? Okay? Just say no. Something you say, whatever you want to say, you say no problem. But don't talk about any movies, huh? We talk about cloud. Virtualization? Okay. Virtualization. What else? Okay, I'll ask one more question to enable you to ask me questions. Okay. Let's say that everybody knows about that web, no? Web hosting basically. Everybody, college also has a website, right? And do you think that college website is there in the campus? There's no server at the campus. Where is the server? Somewhere else in the internet. Maybe the college must have registered something like a GoDaddy.com, somebody else. What they do? They took a domain name and they register with some provider like somebody else, a web hosting provider, and they design a website, and all these web pages are put it onto the web hosting provider. So can I call this web hosting provider as a cloud? Sir, no. Yes. Okay, web hosting is already cloud, then again why to call this as a cloud? Yes? Understood the question? Then I can also call the web hosting itself. Now again why to bring another job like a cloud? Yes? Yes or no? The question is valid. So just think about it. Yes? Cost? What kind of a cost? Setting up cost? Okay? Cost. Okay. Performance. Okay. Any questions? Any answers? Sorry? Processing. Okay. Anything? Question అర్థమైందా? అబ్బాయిలకు అర్థమైందా? Voice? Understood the question? Okay. Now I'll ask the question like this. I designed the website. How do I design the website? On my system, local system, right? I'll pick up some Intel system or maybe some processor with operating system of some operating system. Then I'll put some software called what? Some software for designing web pages. What I'll use? Some HTML pages I'll design. Either maybe Notepad or some other software, Dreamweaver or Adobe, anything whatever I use, I'll design. You also know HTML, no? Everybody knows. Or you also know about some Java, JS based and other things also. .NET based also you can design. So you can also design a .NET based website, and this website you are putting on the web hosting provider. Clear? Looks fine. Now the question is, I also want a system to design my website. Just understand the difference. Right now I am designing the website on my local system. Now I don't want to design the website in my local system. I also want a system which is coming remotely, which will enable me to design the website. How do I do? Can this web hosting person can give me that system? No. What he gives? He only gives you to put a website. Sir, no. But where you need to design the website? On the local system, and you just put it to the web hosting provider. That means when you see right now the web, when you see, it is just a passive. It will enable you to put your content there and probably review the content, but when you want to work on the content, that cannot take it. Yes or no? When you want to work out on the content, you cannot work out. It will not give you any kind of a computing power to design the websites or to design to run your workflows. It will not give you. It is just to enable you to put a content. That's all. That's enough more. Now what I want? I also want a system to design my applications. I need some computing power which can come, which can design my applications. So this is what the cloud does. Right? So you also want a computing power coming from the web. So that's what when we talk about coming from a computing power, getting a computing power from the web is called as what? The cloud computing does it. Right? So just to understand this one more why it is required, let me just say that, okay fine, let's say that I have something called, how many of you purchased laptops? Right, everybody has laptops, good. So how much you spend? Each laptop comes how much? 40,000 rupees? Something 40,000. So 40,000 rupees, fine. So you purchase a laptop when you are at first year, laptop and desktop. And there is one law called Moore's law. What does Moore's law says? The number of transistors on the chip double for every 18 months. 18 months is 1.5 years. So if you purchase a laptop first year, so after 1.5 years it becomes old. So Moore's law, even if you take like another 1.5 years, so 3 years. Now tell me the laptop which you purchased in first year, by this time you may think it's very old. Agree? Under follow now. That's what the Moore's law says. And then the final picture of your old I going to do. How much you spend? 40,000. So how many years? 2 years. So 40,000 by 3. How much it comes? 13,000. 13,000 per annum. 13,000 by 12. Somewhere around 1,000 rupees per month. 1,000 by 30. 30 rupees per day. 30 rupees per day. Now most of the time this system laptop is used for either for Facebook or for watching movies or for chit-chatting. Or you won't watch 30 rupees of spending. But you never use. And just don't think about yourself and think of the companies who are actually trying to portray things. If somebody wants to develop some applications, if they want to recruit something like 20 people, and how much they have to spend? And just, but not with the way of purchasing. Later, it should be maintained. Generally, maintenance issues in the company, but if you go to the company, after purchasing every year, they have to spend almost all 10 to 25% per age. A purchasing cost entuntundo danikante a annual maintenance ki over 10 years of time chusukunte daniki double cost pay chestunnaru. That means you are trying to spend lot of things on just infrastructure management, and you are also trying to spend lot of time even when you don't need it. Now the idea is, if somebody can give me what will be your need. Let's say I just want to use something called I want to run a Java program. If somebody can give me a system, maybe for one day to run the Java programming, I take the system, I learn the Java program for one day. Okay, probably for one day somebody can charge me 10 rupees also. Am I happy to do that? Sir, no. That is where the cloud has come into the picture. Now if you see a cloud, what it does, it actually delivers the resources over the network that you wanted. That is why it is called as the internet-based model which will deliver the resources. Understood? That is why it is called as a utility computing model. And another way you say, it is based on the on-demand. That means whenever you want it, you will get the resources. It is not that whenever I want. Let's say that I want a system which I can work maybe on the Intel processor of so-and-so configuration, so-and-so hard disk, and so-and-so computing power. That if you just place a request, you could be able to see and work on it. The number of hours that you work, you can pay for that. That is what it is called as the utility computing model. The way we use 4 utilities, I also wanted the computing also to come as the utility. That's what it is called as utility computing, cloud computing model. Is it fine? So which we are not able to get. If I ask any that hosting provider, it will not give me the computing power, but here I can get a computing power which normally cannot do. That is why it is called as the cloud computing model. Is clear now? Right, everybody? Now, coming to this, what we do next is, the way we are doing the water, electricity, gas and telephone. So here also something like, there is a web, there is an internet here. So from the internet I just put a request, and the configuration that I am trying to see, that I could be able to see on my display. Now probably you can ask, sir, but the display also to see, I need some kind of a, may have some doubt, no? Fine, sir, computer వస్తుంది బాగానే ఉంది, చూడాలి, మనం వర్క్ చేయాలి అంటే కూడా నాకు ఇంకో కంప్యూటర్ కావాలి కదా. Sir, then how do you get that? That's what I told. Maybe when you see, maybe sometime, your TV is, whatever the displays you have, everybody, all the TVs nowadays are coming as the Wi-Fi network, right? Wi-Fi means what? You are connected to internet. So now you register your system over a cloud. You say that now press that button cloud. Now you could be able to see your system on the sun. That is what is going to change. So what you need, you just need a connectivity. That connectivity can be a wireless connectivity or it could be a wired connectivity. Let's say you are connected to that, probably the display. You may not have that laptop if you take, you may not have a processor. The processor may be a lower-end processor, which could be something long, a small-end configuration processor, but with a good display, and you just provide a connectivity, then you connect it, all your resources will run on where? Somewhere on the net, not on the net. That is where the cloud computing comes into the picture. Now the challenges is the resources are not local. Where are they? They are on a remote. Now how do we manage? How do we develop? What kind of advantage that we get? That is what we should learn when we go for a cloud computing problem. Is it right? Now let's go into the thing. So whenever we see the applications or things, the one advantage is we always try to see that what are the requirements, right? So the requirements when you see for a cloud, it is came from something called as the parallel and distributed computing. Now when you talk about something like when the systems are connected in a network, so what do you need? They are all distributed. Yes or no? So now when you go for the internet or maybe the cloud computing model, the systems are not in one place, they are being distributed. So how do we manage them? So when even in the distributed also, you also need one, the more computing power to come. That means what we need? A parallel. So that's why we say that we need applications, the applications need more power, right? So in order to need more power, what we need? There are some applications which are resource heavy applications, right? Like for example, when you see, there are so many applications. Now you can also think of many applications like the life sciences applications, which we try to do for biological applications, right? And aerospace and military applications, which we try to see for some kind of a CAD/COM and maybe the kind of a rendering applications, or maybe the data processing what we do for satellites, or maybe we have some kind of internet and commerce applications, which generally do the business transactions, right? So there are so many applications which are called the resource heavy applications. So to solve all of them, we need a lot of computing power, right? So we try to see maybe at least one or two applications how to get mapped to the cloud computing models, right? Now, I don't know how many of you heard about the word called as clusters and grids. You have one subject, I believe, that is, I don't know, that's the Kakinada University, which is called as distributed computing. Joseph, George Joseph or something is there. Do you have something called as clusters? Heard about cluster? No. Okay. So cluster is something, no? It's a group of systems which are interconnected together. That's a cluster. So why do you want interconnection? You just think of something like this. Why do you need? Why that cluster is required? You might have heard of something like supercomputer. What is supercomputer? Which can do some more number of computations, which normal systems cannot do. Right? So normally if you select a 2 GHz processor, so 2 GHz means you can execute how many instructions per second? 2 giga. Giga means how much? 10 power? Kilobytes is how much? Giga means how do you say? Kilo, mega, giga. Kilo is 2 power of 10. So 102, but approximately we talk about a 10 in terms of 10, 10 cube. Right? 1000. Then mega is 2 kilos. 10 power of 6. Giga is 1000 meg. You call it a giga. That is 10 power of 9. That means when you see, you can execute approximately 10 power of 9 instructions per second. 2 gig means 2 into 10 power of 9 instructions per second. Approximately, let's say. But it's not exact. Approximately. Now, I have instructions which I need more than 2 gigahertz per second. What do I do? I want to get more than that. Maybe I want to get a system which probably I need 10 gigahertz. How do I do? Just think. Don't go to supercomputer, that will see later. How do you do? Question అర్థమైందా? 2 gigahertz కాకుండా 10 giga కావాలి. ఎలా చేస్తాం నేను? What I need? So probably instead of one processor, I need to have multiple processors, which is called as symmetric multiprocessors. So don't put one, now put some more. So like five processors are combined. So 5 processors are combined. So now my system has 5. Right? So I get 10 gigahertz. Now if you remember, there is one computer which is developed by IBM, it's called the IBM Blue Gene. It's 64 processors. And this computer was designed to run a chess. They designed a chess program which they can play with Garry Kasparov. Right? With 64 processors. You know, they used to say that computer will be probably half of this room. and there is an half of other price they kept it for AC. Generally, when you design a processor, it is not just that you design and do, and there are some maintenance are required. What is that? You would also need a lot of cooling power, and it generates a lot of heat. You cannot go to the room itself. So to cool it, you need what? ACs. So that means they say that computer will be of this much room big, including ACs. And you know, this system has one on the GAN cluster only once. After that, never. They put a lot of AIs also, artificial intelligence also. Now the point here is, when you want to design such a big system, they have done what? They have combined 64 processors. Because what? There are 64 So for each node they want to compute, they put, because they need 64 into some gigahertz computing power, so that much of in the design which is tightly coupled. This is one way of designing it. Looks fine. But what is the impact you see? Technology should be built, it's very hard to maintain, and there is a lot of heat is generated, to maintain cooling power is required, and if one of the processor fails, all the things fail. Now just think of, can I do it better way, some other way? Now just think like this. Why do you want to tightly couple them? There is another technology which probably can loosely couple. Like for example, let's say, I don't want to join all the processors. I have a network. I put each of them like independent system. And all of them I connect, 64 systems I connect in the network.
We should be workshops, we should work. All of you open your notebooks, keep pen ready, and we should make this is like, interactive classroom. And they don't need mic, so they can listen, no? Unless those back, now we can try to come front here, so that we can able to adjust without mic. Like to come front? Can come front? Fine, no problem. So let's start the session. I came to know yesterday you had one session on the basics of the cloud computing, right? So right now what we do that we don't waste much time in teaching the theory. Theory everybody knows. Cloud computing everybody knows now. So the same thing that I used to do for some 3-4 years back. So I used to start in the beginning, teach them all the basics, right? So then come to the understanding, then after that we used to say that okay, time is next, let's go for the practicals. Now the time is not to waste time in the theory, so it's more like doing some programming and hands-on session, and which is required for you, because I hope all of you mostly maybe 3rd or 5th year. Yes? So it should be 5 years? All are 5 years? Yes, sir. This row also? Yes, sir. No 3rd years? Okay. So it's good, so all are 5 years. So by this time you know all the technologies also, including networks, databases, programming, right? So you did not have to spend much time on that. So let's start up the, I spent less time on the theory part. In fact, I thought like I spent 1 hour for theory. Right now I just somewhat compress it and make it to 45 minutes, right? So our agenda will be closing the theory by 11:30. So as much as possible. So then 11:30 what we do that, we try to set up a private cloud. Okay, so how do we set up private cloud? Then after that, how do we create the virtual machines? What we call like virtual workflows. Then access the virtual machines. Then later do some programming and see that how at least execute some kind of programming on the cloud. So at least something like a, what we say, run something like a hello cloud world. Right? So something like hello world, what we write to understand any programming, no? So let's try to see that hello cloud or something. See that how it works on the cloud programming model, right? So later what we do that, once that private cloud is set up, so private cloud which for our purpose, and so once it is set up, then what we do that, we will go to the lab, then use these virtual machines from the lab to the program. Is it okay? So this is with our agenda. So first is learn basics, learn the programming models, then set up a private cloud, create a virtual machines, right? So these virtual machines during hands-on session we will be accessing them to write a programming code. Is it okay? Clear everybody? This will be our agenda. Now what we can do is we can need not be that we will be going whatever is kept in this, because there will be so many things here. So whenever you make some doubts, you can start me, interrupt, you can ask me questions. Is it okay? Right? So and don't think that if I ask question, what my friend will think. So just you will ask questions thinking that if I ask whether it is correct or not, they will laugh at me. No, don't think. If you are asking, so you should be proud enough to say that I asked a question. Okay. So at the end, I will conduct some small question session, and whoever answers well, I will have a small surprise gift for you. Let me see how much you can answer my questions. Okay? Right? So this will be my agenda for today's. Now we'll just try to see that what is cloud computing, which we call as revolutionary information technology, which is also called as the utility computing. Right? So later we'll go for what is the need for the cloud computing. So until then there is some requirement, the technology will not evolve. Like for example, we see like C++, Java. After Java, again there are some other languages which are coming up. And parallel to that also there are some other programming languages like C# also coming up. So there is a requirement. Right? So if there is no requirement, why C++ has come? If the C itself can able to solve the purpose. It's not like that, right? So that means there is a requirement. That's why new technologies are always evolving. So we should try to see what is that need, and also see that how these technologies will meet those requirements. Fine? So this is what our new technology will grow. We'll try to see the applications covered. Now let's see, we'll understand the differences. So probably the cloud, when you go, obviously those who are learning these technologies knows there are so many questions. Probably you may not have, probably the faculties may have the questions, because they know about other technologies also. So when you teach any subject which is very new, it's very easy to understand. But when they try to correlate with other technologies, they try to say, what is the difference between them? We always try to see. So when you see the differences between the other technologies, then always you have so many questions in the mind, right? So we try to do that, we try to understand how does the cloud computing differs from the existing technologies. It could be web technology, it could be internet computing, or previous to that there are some other technologies that we try to see how does it differ. So and how to use these technologies, clouds, right? So then we also try to see the types of clouds. So we have 3 different types of clouds, like a private, public and hybrids. So hybrid clouds and public clouds, that could be, we'll try to see how we access them. But if I want to use my own type of setup, so how do I do that? So that's what is a private cloud, that will set it up today for our practical sessions. Now next is, coming to that, we have one more technology which is called as infrastructure virtualization. So for you to understand infrastructure virtualization, so we can take up something like operating system, everybody knows? What's an operating system? Yeah, it's something like, it's a bit like an interface between the user and hardware. It's like a manager, which manages basically the different types of users working on the hardware systems. And also gives you an interface for a hardware systems for you as a user, right? So like this manages, there is one operating system which is called for a cloud is the infrastructure virtualization, which is called hypervisors, right? So the hypervisors is the one which is called as the infrastructure virtualization, which is meant to create a cloud operating system. Like what we have the Windows, what we have the Linux, and what kind of flavors we have. So we can treat like hypervisors are basically the cloud operating systems, right? So we'll try to understand those cloud operating systems in this infrastructure virtualization. Now once we have this, we also should be able to understand the different types of the technologies of the clouds, or different types of the offerings of the clouds, right? So like you see, there are some public cloud offerings which probably you need not to set up. Like for example, I don't have some kind of a resources, I don't have a money, or I don't have any kind of thing, but I just want to use, and after that I just want to have a feel of it, then after that, okay fine, I don't want to use after that, right? So those kind of things are available, which is called the public clouds. If I want to set up my own thing, which are the private cloud, so if I want to do, how do I do? Right? So this is what we'll try to see when we come to the public cloud. And we'll have some slides which actually takes you how do you get an access to the cloud from the internet, right? So that's what we'll try to see in the public clouds. Now the next one is, this is where we try to see now for today's hands-on session. If I want to build my own cloud, how do I do it? So to build it, what we need a cloud operating system. So we pick up the cloud operating system and put the cloud operating system in the hardware. So we arrange the system, which is one i5 system, which is Dell. So because that system, we use one system only. Similar to that, you can put n number of systems and make it like a complete cloud setup, right? But as a hands-on session understanding, we'll put one system, make that as a cloud, and we'll go to the lab, connect that system, and you do the programming part. Okay? So that's what we'll be doing with the building our own private cloud. Later, any resources to access, we need what? Programming models. Right? So like what we have, the C language, Java language, C++, or object-oriented language, the databases, the different kinds of languages which are there, but the clouds which are coming up, these languages are not just enough. Right? Fine? So we need a different set of programming models. The different set of programming models which we will be using for a clouds are the high performance model. Everybody knows about the threads. What is a thread? Small, lightweight process, right? So where that all, if you see the threads, so it's like a process is going into multiple units, and all of them will share the same process ID, but each of them will execute into their own thing, but they have a shared variables which can be used among them. That is a lightweight process we call. So it's similar to that. When you come for a cloud, there's a high performance model which uses the threads, right? But the threads, when you see, normally the threads execute where in the local system, but when coming to the cloud, you need to have resources coming from different geographical distributed systems. Not from a single system, but it has to come from multiple systems, right? So you need to have the threads which are executing on different systems. May not be on the same, but they are on the different locations itself, right? So in that case, how do we do it? How do we get an access to them? That can be done something called the high performance models, right? So this is a new model which we need to learn. To learn the cloud programming, so we need to have some high performance model which will give you to execute more number of instructions in less time. Is it right? That's what high performance talks about. So we need more performance. The next one is the high throughput. So high throughput is the difference between performance and throughput is performance will talk about it reducing the instruction time for a single instruction, the time for a single instruction. When you go for a throughput, it talks about reducing the time for multiple instructions or multiple jobs, right? So when you talk about a single, you talk about the performance. When you talk about a group, you talk about the high throughput. So that is where the difference comes for a high throughput. Now next is there is another one which nowadays is coming up, something called as the MapReduce models, right? Heard about MapReduce? Or it's also big data. People are talking about big data, no? What about big data? So the big data what it talks about, there is a large data which needs to be analyzed. So to analyze this large data, we need lot of computing resources, and these computing resources need to be exploited. So you need another programming languages for this which are called as the data intensive. Right? The data intensive models are called as the big data which is called as a MapReduce models. Right? So these are the new programming models which are being evolving. So these evolving programming languages, we should be able to learn them and incorporate in our things and see that we could do some kind of interesting projects when we go for our final year things. Is it okay? So that's what we should keep it able to learn all this programming model and see some projects pick up which could be useful for you when you go for the industry. Right? So that's what we should get ready for yourself to make it ready for the industry. Now next is any technology to come into the market, until unless we have few case studies. What is a case study? It talks about the applications. So until we have a feel of a case study, we cannot make how this technology can be useful for you. Right? So to understand it, we're trying to see what are the different kinds of case studies here. So I'll provide you some kind of a case study which is for high performance thing. I'll also talk about one case study for mobile applications, and also we'll see that another application which can be general purpose application. Right? So these three things we'll see: scientific study, mobile applications, and some general purpose applications. Right? So these things we'll study for coming to the case studies. And pick up those case studies and take your problem, map it to those case studies and try to do it in the technology which are being developing. Okay? Fine. So this is what we try to see. Then later we'll go for some example program. And I'll give you some summary and references which will be useful for you to go for your projects. Right? So this is what we have agenda today. Now later in the afternoon session we have once we have a parallel cloud setup today here itself, these systems will move into the lab and use those systems for a hands-on session. So this we will be doing it in the afternoon session. Is it okay? Other thing? Outside the states, nearby to Odisha, nearby to India, Vijayawada center was the problem with that. So last time when I went to somewhere in the Rajam, that side, there are people from Odisha. They said, sir, I don't know Telugu. No, Vijayawada doesn't have a problem. All are from Andhra. Okay? Andhra Telugu kada? Appudu Telugu appuntaru. Maybe sometimes it comes up. Now this will be our agenda, so we'll go to London. Is it okay? Right? Any questions?
No questions.
Now let's see that why do we call the cloud computing as the revolution in IT. So whenever we go for learning at technologies, IT technologies, we always try to see the predictions, how these technologies are evolving, right? So the Gartner is basically a company which is worldwide company which does the technology predictions. So it takes some statistics and it estimates and see that the technologies are all evolving. And in the evolving, what are recently coming up, what are already there, and overall high, and overall stabilized, and overall coming to productive, right? So there are some hypes. Hype is what? So chala maatladestharu vaati gurinchi, but untundalane teliyadu. It's a hype created, right? So during this hype also there are some technologies which will get stabilized, so they come into the productivity. So this is what the graph talks about. So when we see here the Gartner, the 2004 predictions we see, the most of the thing which you see, the graph talks about the clouds, right? Did you see here there is something which I mentioned here. What is this? It's a keyboard. So in the keyboard if you see, right now in the keyboard, you have some keys, no? So it predicted that maybe end of this year. So on a keyboard you will see one symbol, maybe one key with a cloud. So you press that cloud button, then what it happens? Your system will get connected to the cloud. That's what it says. It is becoming as an integral part of IT. That's how the technology is moving. That means you get a key which will be there, which you connect, and you will be connected to the cloud, which you register for. Which will automatically come to know where you are registered, and those resources will be given to you on your display. Right? That's how the things are. That's how the predictions was done. And later there are some other things like the CRM, which is called the customer relationship management, which is CRM applications. So they're also moving to the clouds. Like I don't know how many people have heard of something like a SAP. SAP, SAP SAP. What is SAP? Not SAP. SAP, SAP. SAP is basically it's a CRM application where the industries will use for some putting that especially for what do you call maintaining the transactions between the customers and the industries. Right? That's basically that SAP application is a CRM application. So we see that the SAP application which is called as a CRM based SAP applications, SAP applications for CRM, most of them are designed local. Right? Now the thing is, those applications will be going to the cloud. That means no development will happen on the local system, but all these development will happen on the remote systems. Right? And also the applications and the databases and the connectivity, all the things will come from the remote. That's what the CRM goes. That means all the applications are going to the clouds. Now the next one is obviously the clouds and services security, which is becoming as a major thing, major problem. The next is all the things that you see, the software as a service. So you use the services and pay for the services that we consume. Right? That's what all the predictions done for the Gartner 2014 predictions. Now, why we need to learn the technologies? So whenever we as a students or as a technology we see, we always try to see that, sir, but is it necessary to learn the technology first of all? Does it got any growth? Right? So the predictions was done by 2015, this technology is going to create 13.8 million jobs worldwide. 13.8. So when you go for this, so that means we should be ready to grab these jobs. Second, that means we should learn the technology which will give you a scope for us to put it into the latest state-of-the-art technologies. Right? So this is what we try to see this. Now this is 2011 to 2015. Now the next stage is, when you see this is what the hypercycling. It was 2012, but every year, every 6 months they release the predictions. So it was 2012 and 2012 you see, did you see when the cloud computing is here? So this thing indicates is like a high. Now later, once it comes here, the slope of enlargement, that means people started realizing that, and later it comes to the productivity. Productivity means what? It comes into the industry producers, right? And there are some technologies when they are here, they may get vanished. They may not come to this production, right? So where is the cloud now? This is here. Is there big data? Big
big data also here. This also hide in 2012. Both are there. This is the big data, this is for the cloud computing. Now let's come to 2013, which was July. Now let's come to 2014. Now this month it will come. Now if you see here, where is the big data? In 2013, if we talk about big data, still was on high. Server. Now the cloud, when you see, where is the cloud computing? Is here. That means most of the 2013 not is being realized. That means people started realizing it. So after that, what happens? It comes to the production, right? So now this is what is happening. When you see the same thing in the probably 2014, which will be released in this month end. So probably the cloud can be here because it's been come to the production. Now where the big data will come? Big data when the cloud is there. Now the big data will occupy that. Because big data is also getting realized. And whenever we talk about big data has come into the picture, or big data has come into the reality because the background is the cloud. So that's why I said that big data is one of the applications or one of the technologies which evolved from the cloud computing technologies. Right? So that's why these two things are closely interrelated. Now let's go to the cloud. What is cloud? Let's understand. Whenever we talk about a cloud, how we always think that cloud means why this is given the name as a cloud. Somebody was asking, there is one place called Krishnavanka. So, person Ravi Kumar is Madras asking me because it's like a Krishna river. There is something Lanka is something like associated something, right? Krishna Lanka. Krishna river is there. So like this, whenever we say name, we try to say, sir, is there any relation? So cloud computing people think, oh, there is something relation to clouds. Cloud formation, no? There is not any relation, right? So this is what we have in mind. So now we see that what general cloud thinking is, the cloud when you see, it actually said like this. How do you represent internet? How the internet is represented? Like this symbol. And how does it look like? Cloud computing means what? So basically an internet based. So that's why people know whenever we say cloud, they think, oh, it's a new technology which is came recently, no? Very recent, I mean, it came as it is, no, something like a mushroom growing. Mushroom, old if you see, no, it grows like its own, right? So night in the it will grow on Mars. So like this process, cloud computing has come, no, by night, overnight itself. Nothing. But to grow, it has taken so many years. Right? Let's see that how it is done. Like, what is the cloud basically is? It's a transformation of the internet. The transformation of an internet into a usable model is called as the cloud computing. Is it right? Now you see there is the predictions, even the two uses of the cloud to come into this picture. Basically, this was started in 1966 itself. It's not a rule. Only thing is now it came to the thing because the technologies have grown. 1960s to 2014. How many years? 2010. Something like 50 years. Right? Is it right? 50 years. So 1961, everybody knows about this ARPANET project. ARPANET is called as Mother of Networks. Right? So those who are the designers of the ARPANET project and we consider to be John McAfee, he is the computing artificial intelligence and modern processor. The second one is the storage and the other one is the network. That is why it is called as the IaaS, infrastructure as a service. This is called the IaaS. This is the IaaS. But you ask like, sir, but why it is called as a service? Infrastructure is okay, but why is it called as a service? Why as a service? Do you know why it is called as a service? You can create the virtual machines on demand. The machines you can create on the demand. Let's say, for example, I just tell you something like this. Sir, I just want to get a system. Maybe with 512 MB RAM, with Windows 7 operating system, having 40 GB hard disk. This is what I want to get. I want to create. How do I do? So what you can use? Whenever you take any virtualization layer, it comes with application programming interfaces, APIs. You design a website. Put a website in your college, maybe one of the system. Now you create a login to you. Now you make a website such that what is the how much RAM you require to put like a drop down button, how much disk space is required to put like a drop down button, what is the operating system is required to put a drop down button, just submit. Background you use the APIs of this hypervisor like a Xen. And when you give and commit here, it automatically creates a system, attaches the IP address to that, and it will give that system. Now click on that, you will be able to see the system. This is what is called as service. That means based on your request demand, the system is created on the fly and it is given to you. That is why it is called as infrastructure as a service. This is what the public clouds like Amazon or Windows Azure does. So they give you the interface on a web, just put your request and just submit it. The machine is created on the infrastructure and they will give you the host name IP address which you can see on your system. How it is happening? Background there is infrastructure layer which is created. It is picking up your request, creating a system, and how does it create? Right now we have only one system. So like this, I can create pool of systems. Yes or no? I create a pool. How do I create? Whenever I go here, right? So here, I'll show you through that another one, which we can create a pool, where you get a pool. So what we can do is, we can create multiple systems, put multiple systems like this. So these systems can be identified when you want to have more requests for the scalability purposes, and put all of them, load them server, make them as a pool. When you are in a pool, when you submit a request to the pool, when you write the programming and submit it to the pool, you need to write the programming and submit it to the pool. Now the pool understands where it can pick up the resources. Like for example, I kept 10 systems like this. Now let's say that this system has how many cores? I think it's a quad-core system. It has, that we can check up how many cores it has. Hardware and balance. Processors. How many? Total CPU sockets are 1. Populated is also 1. Logical CPUs are 4. That is, how many cores it has? 4 cores. Do you know how many systems I can create on this now? 4 systems. Even if it has 1 processor, I can create 4. Each system will run on 1 core. If you see physically, it looks like a 1. But this one is able to deliver you the 4 systems. That is what we call as high utilization. That is why it comes like a virtualization, which you cannot do by the normal operating systems. Now like this, let's say if I keep another system, add to this. It also has a quad-core system, let's say. Then what it happens, how many get I get? 8 cores. How many boxes you have? Only 2 boxes can be able to provide you the 8 machines. That is what these public clouds people will do the jadoo. That's why they say, but illusion of having many things. They say that we provide the infinite resources, no problem. Nothing is infinite in the world, everything is finite. Only thing is, they make some magic. Somehow. How do they do magic? If there are some more requests are coming, they add another box, scalability. And they say it's over. What is that? So whenever you want, you give me, I'll give you. And do you know what they do? If somebody is not using the resources, using the scheduling mechanism they are mapped. Whenever you put a request, let's say I have something like 10 boxes. Each box can be able to provide you the 4. 4 into 10, how many? 40 machines. So they take a request saying that, okay, which code I have to map? They do some kind of scheduling and the requests are mapped to that code. That is what the virtualization does. And there are some other virtualization software, the same thing. When you go for commercialized virtualization software, they could be able to provide you the 1:8. In the sense, the 1 core can be used to deliver 8 machines. So in that case, 1 box is able to deliver you 4 into 8, 32 machines. So now you see, 1 box will cost you only 40,000 rupees. This could be able to deliver you the, if you are going for enterprise versions, 32 machines. So what it does, it utilizes the resources. Which probably if you take your laptop which you are not using the resources, when you put these kind of softwares, it will utilize the resources effectively. That's why these technologies are becoming popular. And you see another one is no request, no? They don't take your request on steady. What is RAM you are asking, what is the operating system you are asking, what is the hard disk you are asking, what is the network you are asking. Nobody will take the request and they put a CD, they create nothing of that job. What they do? Everything is automated. Or the APIs are provided, you put a request, those APIs will automatically talk to the system, they will automatically create a machine, they will automatically assign IP address, they will automatically put a host name, and this host name will be given to you. Just click, and everything will be done in fraction of minutes, probably some 10-15 seconds. To load operating system itself will take 10 to 15 minutes, but these people could be able to give you within fraction of 10 seconds. That is the power of cloud. That's why clouds are becoming popular. Understood? Clear everybody? Now let's say that if I want to create of such kind of things to get it, how do I do? So I create a virtualization, I put only one system, but we can add some more systems like this and do the pooling kind of a thing, but I put only one system and create a virtual machines and try to access it, right? So generally, the hypervisors when you put something like this, so to access to see, like when I create some more 4 or 5 systems like this, no? Do I need to physically go and verify for each system? Don't need. All these things can be controlled from using a single software which is called as CentOS, which are called the management softwares. Right? So now right now what I do is, I take this management software which is called as the Zen Center, which comes along with the CD. Okay. Don't make noise. This 10 seconds, if I won't speak after 10 seconds, you make noise.
మీరేంటి వాయిస్ ఎంత అనేసి ముందు కూర్చున్నారు ముందు సరిపోలేదా మెడికల్ కూడా నిద్రపోతున్నారు మీరేంటి
10 hypervisors, 10 servers which I loaded. So instead of going physically to each of them and to see the screen, very difficult. So to manage all these cloud resources can be done using one manager software which is called as the CentOS, right? So the Zen also comes with the management software which is called Zen Center. Now we load the Zen Center. When you take that downloaded file from the internet, 650 MB of file, that file comes along with the Zen Center also. So same CD you put it on your Windows system. And the center runs generally from Windows. Windows XP, Windows 7 or Windows 8, right? Yeah. So now what I do is I load that Zen Center. VMware is one company which gives the virtualization software, and there is another one called Zen, which is the commercial software like Citrix, and also there is an open source Zen. Zen virtualization was developed by Cambridge University, which is the way like Red Hat, Linux, all the Linux flavors. So they have developed one virtualization software on the Linux, right? So that they named as Zen because it's open source based, and that's why it is open source. We can use the Zen, no problem. But if there is a support, you need to get it from Citrix. The administration was done by Citrix. But right into the open source, so we can use them without any problem. This can be downloadable from the net. You go to the site www.zen.org. Zen? Excellent Zen. Zen.org. You can download it from somewhere around 650 MB, megabytes. Okay? So download it and cut this as the bootable DVD, bootable CD or DVD. Now this, put it on your system, then you start loading the virtualization Zen.org. Okay. So similarly, and also if you go for another one, there are another open virtualization software called OpenStack. OPEN, Open Stack, STACK. OpenStack is also another software which you can create a virtual machines, right? So OpenStack you can use, but OpenStack will take some time. But the concepts are same, and OpenStack also needs 2 more systems basically to set up that. So instead of this, we'll try to see learning the Zen today. Okay? So this is the Zen software which I am using. And what is the type of virtualization we are using? Bare metal. So bare metal means if any operating system is there, it will wipe out. So if you are trying to put it on your laptop and if you want to load a Zen, be careful to take a down. And if I don't want to make it as a bare metal, maybe for my development purpose I am using, not for providing any kind of a production support, then what probably I try to do? I can go for virtualized software like VM Player, VM Workstation, VirtualBox. So you should have a clarity. Zen, we are loading Zen now. Why? Because I want to give virtual machines for all you people. Yeah, bare metal means it will load directly on the hardware. Load directly on the hardware.
That means if any operating system is there on that system, it will be erased. Okay, that's a bare metal system. It will be erased. Because now you are trying to use this cloud, which I am going to set up. That's why I am making it as a, I am selecting what? Type 1. If probably I could have want to use for my own purpose, what I could have chosen? Type 2. That's it. Okay, clear now? Now let me see how do we do that. Now we have placed it. Let's check that out as well. Set up. We need to detect from the CV. No, Windows not has a problem. Doing something is doesn't mean that you talk. Okay. So I want to boot it now. So I want to make it as a bootable CD. It is booting from the disk. So I am making it as boot from DVD. So I need to change. My first boot is what? CD, DVD. Next boot is hard disk. Right? So save F10. Yes. Times వస్తుంది. Okay, let it boot. Go for installation of 2 years, no? It will take hardly some time. Wait, no problem, we will install it. Today we have to work. Today we need to work. Okay, so I'm going for what is the time installing? That, right? So it shows once you click the CD, it will ask you whether you want the keyboard is yours. Okay? Or to change now. Did you see this? The setup tool can be used to install or upgrade or restore your server from data. Install then erase all the data. It is a bare metal. If you install VM Player or VM Workstation or VirtualBox, they won't ask this. Okay? So it's a bare metal, so that's why you need to take data 1. Okay, no problem. Now accept EULA. EULA is end user license agreement. Now how much storage it has? 149 GB. Okay. So then you ask whether you want to enable thin provisioning. That is for Zen Desktop. So Zen Desktop is another software which will deliver you the desktops. Like generally for remote system access, you are sitting here and there is a remote computer. There is a computer there. How do you access that system? Through remote desktop. Correct? But remote desktop protocols are not meant for cloud deliveries. Are not meant for, in the sense they are not good. They won't get quality. Right? So there are some other technologies which are developed which is called as the virtual desktops. Virtual desktops. So that is called as thin provisioning. The technology they use is thin provisioning for the virtual desktops. Okay. So if you want to do that, you should enable it. Right now what I will do is I will not go there because I am not virtually, I am not going to access. I am going to access them via remote desktops. Right? So that's why I am not using Zen desktops. So I will only use only the remote desktop to do that. Now local media, yes. What is HTTP? If you want to take some source from the web, and whether you want to have some mounted, then you go for NFS. NFS is network file system. So I will just local media. Let's go for this. Would you like to apply any supplement tags? Any extra software? No. Whether you want to verify whether this CD is correct. So I know that this is correct one. So I will not do. So I skip verification. Okay. Then I need to give a password. So this password I need to use. So I will give them as test 1, 2, 3. TEST 1, 2, 3. Again, TEST 1, 2, 3. Test 1, 2, 3. Okay. Now the IP address I need to assign. So I go for some static. Because network is must know. Network lekunda cloud radu. Kada? So I need to have a network. So to have a network, what we have done is we have connected one switch here. So this is 4-port switch, 4 or 8 ports. 1, 2, 3, 6 ports. 6 port hub is there, right? And the hub or switch, you can call them as a hub or switch, doesn't matter. So I connected. So what I do that? I connect because I need to use the virtual machines now. So the virtual machines have access from my laptop. So my laptop and this machines both are connected. Okay now? Right? Fine. So the network also established a private network. Now, I need to give the IP address. I assign the IP address as 10 dot 1.1 Kali means free IP. Okay, 10 dot 8 dot 88. Okay, I'll do that same so that I want to do the same. 255 dot 255 dot yes 255 0 dot. Then gateway, handle gateway, dot 1 dot, 8 dot. 1 dot. Then the host name. So can I give this host name as, tell me what is that you wanted? Huh? PSCMR. Sure? PSCMR cloud. Do you have any DNS? Or shall I do the same? 10 dot 8 dot 10 dot 8 dot Same. Manual time entry. Install. Send. Let it go. Again, the type 1 hypervisor. Type 1 is what? Bare metal. The type 1 bare metal hypervisor is again classified into two. The two classifications. So one is called as the full virtualization. Full virtualization. The second one is called as para virtualization. PARA, para virtualization. So the difference is, in the case of full virtualization, there is no operating system. There is no operating system. In the case of para virtualization, the virtualization runs on operating system. Right? So full virtualization, there is no operating system running. Underneath, there is no kernel operating system. But para virtualization, there is already an operating system running, right? Zen is an example of the para virtualization. So it is a type 1 comes under para virtualization, right? So the operating system on which it runs is the Linux. Linux is what? Open source. Zen is developed on Linux open source system. That is why it is called as the para virtualization. Though it is a type 1 bare metal, underneath it comes as the para virtualization. That we see when you load and see, you could be able to see the Linux commands which will be running on it. Clear? It's an example of para virtualization. Coming to the full virtualization, the tools for full virtualization are the VMware. VMware is an example of full virtualization. In the case of full virtualization, VMware built their own kernel. They are not put from any of the operating systems. That is why it is called as the full virtualization. But there are some other differences. But right now, just understand, full virtualization doesn't have any other operating system, but para virtualization has operating system which is running. Now, can I call now? Let it go. By the time I will need to explain some more things, right? So, when you call this para virtualization now, just think, can I call para virtualization as a type 2 hypervisor? Stop now. Why I can call type 2? Because it is running on operating system. That is why the type 2 para virtualizations are called as the hosted operating system, bare metal hosted virtualization software. Para virtualizations have got a close relation with type 2 itself, but it's not actually the type 2. It has the properties for both type 1 and type 2. That is why it is called as the para virtualization. Is it right? Because now the Zen is based on the open source. That's why it should be made Linux operating system. That's why Zen is the open source. It can be freely available. Right? So that's what we are using to set up this. Now what's the day today? 26 only. Time is 12:06. Okay. Now we need to please remove local media. So it has come out already. So I need to remove. see the virtualization layer. Now you know when the public clouds like Amazon, when Windows Azure are created, public clouds like Amazon uses Zen and VMware both. So what they would have taken? They have taken the hardware. On top of it, they put a virtualization layer. Windows Azure uses a cloud operating system hypervisor called Hyper-V. So they take the server and load the Hyper-V. Okay, that's what Windows does. Windows Azure. Now right now we are using Zen. Now later we'll see what is the advantage, why do we need to do that, all those things we'll try to see. I think that IP 10.10.8.8. If any clash is there, that we need to reach it. This is how the Zen server. Okay? Is it okay? Now, what we need to create? This is the virtualization. Now we need to create what? Virtual machines. Virtual machines. We need to create a machine. So to do that virtual machine creation, so let's just check this. What do you call it? The other resources. No. This is the for distant storage. That is. That will change it. Once we create and change it. Once we take it, this change it by this GUI. It will tell you about the status, this IP address what we assigned, then the resource pool, hardware balance information, log. Okay. Now, what is the password you have given? You will see this. What is this screen looking like? Command prompt of what? So it's genuine. That means it is running on the back. Did we load Linux? Did we load Linux explicitly? No, it has come along with the bundles. Because it is running on the Linux, already it is coming as a hosted, but it directly loads. And whatever you create, you know what it happens? The internally using the Linux operating system, when you create a Windows virtual machines, or maybe let's say that I want to create now different machines. Maybe one is Windows XP, other one is Windows 7, or Windows 2003 server, Windows 2008 server, or Linux or different players like Ubuntu, or maybe the Fedora, or RHEL, or any other things. If I want to create, I can use this system to create multiple operating systems. Now there is only one processor. There is only one hard disk. There is only one network card. But this will enable me, even though they are all one, but the hypervisor like Zen will enable me to create multiple operating systems to run parallelly, which has partition disk attached. Even though I have a single network card, I can attach multiple IP addresses of different IPs. That is where the virtualization comes. So what we are trying to virtualize? One is the